Hello students, in previous class we have learnt what is the meaning of electric charge and some of the properties related to the electric charge. Electric charge, it is the property or the characteristics of a matter that's going to exert the force on the other matter. This is the simple definition for the electric charge. And charges are conserved, and the thing that the charges can be added. The unit for the charge is coulomb, and our single electron contains 1.6 into 10 raised to minus 19 coulomb of charges, whereas 1 coulomb of charges contains 6.25 into 10 raised to 18 electrons. So these things we have discussed in the previous classes. Now let me move towards the next topic. One thing that we know that sometime what will happen, if you have touched the sweater suddenly, you will get something shock. You will see the something cracked sound in that one sweater. Okay, so here what will happen, that sweater is also a matter. So when you have touched that one, you will feel that something shock. Okay, so that is nothing but something that the movement of charges, the charges are going to be exert the force. Okay, so that is we have called as static electricity. Static electricity. Which means it deals with the charges at rest. Fine. The object sweater was there, we have touched it suddenly, you will get something crack sound or you will get shock. So here what will happen in that one situation means the charges are at rest. So if the charges are at rest, so those charges we will study the branch of electricity or the types of electricity, that is static electricity. And one more type will be there, that is current electricity. Current electricity. Current electricity is, it deals with the charges in motion. Deals with the charges in motion. So here in this one branch of electricity, we will study that one. If the charges are in motion means what will be the effect we can see. Fine. Okay. Now let I define you the term electric current and circuit. This is the first topic in the current electricity, electric current and the circuit. This is the first topic. Fine. So in order to understand this one, the electric current and the circuit, let I consider one diagram which is having the electric bulb and one device called as ammeter, which is connected to the switch, and switch is connected to the cell or the battery. Here this is cell, this is the switch, symbol for the switch. Later we will study in detail. Now presently just remember, this is the symbol for the switch, this is the symbol for the cell, and this is ammeter. This is ammeter, and this will be the bulb. Fine. Now This electric cell is a device which will convert the chemical energy into electrical energy. This is a simple definition for this one. Later we will see. Now just you remember, electric cell is a device which will convert the chemical energy into electrical energy. So switch, you know that one, how it will work. Now let's suppose that one example I will give. We have the torch. In that one torch we have the electric bulb, and we have the number of cells, 2 or 3 cells will be there. When switch is on, the torch switch is on, you will see that one, the electric bulb will glow. The electric bulb will glow. So somewhat we will call this one as current, right? So if we are getting the light, we will call this one as current. Okay. Now here in this one case, these lines, whatever the lines I have drawn, these lines are represents the conductor. So that is the wires. That is nothing but the copper wires. I have taken one cell, connected with the wire, copper wire, with the electric bulb, and we have the device ammeter, and we have one switch. Now when switch is on, here we have seen that the bulb will glow. So when bulb will glow, we will call this one current. So actually, what is the meaning of current? So let I just expand this one. Let I suppose that one I have taken the just part of this one wire here. You know that one, the copper wire, as it is a conductor, it contains electrons. Now when this one copper wire is connected to a electric cell, we have seen that these electrons are in motion. So when the electrons are in motion, means that effect of that one motion of the electron, we will call this one as electric current. Fine. Now let us suppose that when switch is on, through this one, the cross section, this area, we will call this one as cross sectional area of a conductor. Now when switch is on, there are the many number of electrons are in motion. So all the electrons are just moving like this, all the electrons in this one wire. Okay, so all the electrons are in motion. So when the electrons are in motion, we will call as electric current. So here the flow of electrons called as electric current. In simple words, flow of electron is called as electric current. Now you look at here, there are the many number of electrons, that is the quantity of charges is passing through this one cross sectional area of a conductor in time t. It is called as electric current. Once again, in a conductor, the quantity of charges passing through a cross section of a conductor in time t is called as electric current, and the electric current is going to be represented with the symbol, that is the capital letter I. Okay, let I write that one more definition. Electric current is the quantity of charge charge, quantity of charge passing through a cross sectional area, of a conductor is called electric current. Mathematically, I is equal to Q divided by T. I is equal to Q divided by T. Here one more word we need to add. In time T or in unit time. In unit time. That is, without the time that we cannot say that how much time electrons are moving. It is called as electric current. Okay. It is unit time. Symbolically, I is equal to Q divided by T. Look at here. Once again, I shall repeat the thing here. Electric current, the amount of charges, that is the quantity of charge, it is passing through a cross-sectional area. If you consider this one cross-sectional area, how much amount of electrons are passing through a conductor in time T. That situation we have called as electric current. Mathematically, I will write I is equal to Q divided by T. Q stands for the net charge and T stands for the time. Now here, as this one, the charges that I told you, in conductor, who will carry the electric charge? That is, electrons will carry the electric charge. Now, when the switch is on, these electrons in motion. So, who is carrying the charges? Electrons are carrying the charges. And you know that when electrons are negatively charged particles. Fine. Here, negatively, as the electrons are negatively charged particles, these electrons will move from negative terminal of this cell, this one negative terminal of the cell, they will be in motion like this. They will be in motion. But here we will take the direction of current from the positive terminal of the battery or the cell. Why? Because when this one electricity was invented, at that time the electrons, the discovery of electrons was not there. It was not found that one electrons. So they used to think that only the thing that there are the charges, positive and negative charges. There is no idea of electrons. So because of that one, the direction of electric current conventionally we will take from the positive terminal of the cell or the battery. But actually, what is the thing is there? The movement of, that is the motion of electrons, that is in simple word, flow of electron is called as electric current. So here electrons will be in motion from the negative terminal, but we will take the direction of current from the positive terminal. Okay, so this is the direction of electric current and this is the direction of electrons. This is the direction of electrons. Now, as this one, the charges as the quantity, it means we can measure the electric current. So in order to measure the electric current, we have the device called as ammeter. So ammeter, it is the device from which we can measure the amount of current in a circuit. So here I have used the word circuit. So what is the meaning of that one? Circuit. one simple thing we need to understand here. Now let us suppose that when switch is on, electric bulb will glow. Now when switch is off, electric bulb does not glow. So here what is happening here? When switch is on, there is a flow of charges. Continuously. There is a flow of charges in this one path, in this one wire, the conductor. There is a flow of charges continuously is there. If you are stopped, if switch is off, means there is no flow of charges continuously. Okay. So here this one wire is going to provide something path for the continuous flow of charges. So that path is called as circuit, right? So here electric circuit is a continuous and closed path for the flow of electric current. Called as electric circuit. It is called as electric circuit. Look at here. It is just a closed, right? It is a closed and continuous path for the flow of electric current. Now if I broke this one, the bulb does not glow. If I broke here the wire, if I cut the wire, the bulb does not glow. So here this path is closed and there is a continuous flow of charges. So we will call that one as electric circuit. Okay. Now as this one having the electric current, we can measure by the device ammeter. It means it should have something unit. Okay. The current should have the unit, then only we can say that when this much amount of current is there, this much of current is flowing, we can say this one. Yes. Now current is having the unit. That unit is, according to the formula, we have the unit is coulomb per second. Look at here. I is equal to Q divided by T. This is the formula according to the definition. What is the, here Q stands for charge. What is the unit for the charge? It is coulomb. T stands for time. What is the unit for the time? It is second. Therefore, coulomb per second, it is the unit for the electric current according to the formula. But here we will take the SI unit for the electric current is ampere. Ampere denoted by the letter, that is the capital letter A, in the honor of the scientist called as Andre Marie Ampere. In the honor of the scientist Andre Marie Ampere, we will take the unit for the electric current as ampere. Okay. Now, when we will say the current is 1 ampere, means when there is a flow of 1 coulomb of charges in 1 second. So let I draw the circuit once again in order to know it clearly. So here I have taken the electric bulb, here I have taken the electric cell, switch, and this is the ammeter, negative and the positive, and this is the direction of the electric current, always from the positive terminal of the cell or the battery. Ammeter, it is the device which measures the electric current in the circuit. Fine. Now this ammeter I have connected in series. Remember this one, a very important thing, that how the ammeter is connected in the circuit. It is connected in series. It is connected in series. Why we will connect it in series? Next topics will be there. At that time I will explain why the ammeter is connected in series. Now presently you remember this one, that ammeter is connected in the electric circuit in series. Fine. Now if you wanted to say the amount of electric current, the current is 1 ampere in the circuit. So when we will say the current is 1 ampere, when means when 1 coulomb of charges, are flowing in 1 second. 1 second. You know that 1 coulomb of charges means how many number of electrons? It is 6.25 into 10 raised to 18 electrons. Fine. So here in this one cross sectional area of any conductor, here in this one conductor, if this much amount of number of electrons are flowing per second, means we will call this one as 1 ampere current. We will call the current as 1 ampere. So here current is said to be 1 ampere when 1 coulomb of charges flowing in 1 second. Okay, in 1 second, it is called as 1 ampere. Let us suppose that if current is 2 ampere, if you wanted to know that what is the meaning of 2 ampere current, means when 2 coulomb of charges are flowing in 1 second. When 2 coulomb of charges are flowing in 1 second, we will call that is 2 ampere current. Similarly, if you wanted to say 5 ampere current, it means 5 coulomb of charges are flowing in 1 second. Are you getting? Similarly, current is 10 ampere, means 10 coulomb of charges are flowing in 1 second. So this is the meaning of this 1 ampere current. This is very important for the examination point of view. Define unit of current, means at that time you need to be write the definition for the, that is the meaning of 1 ampere current. Now let's suppose that the current, the amount of current is very small is there in the circuit. So is there any smaller unit to measure the current? Yes, the current is having some smaller unit to measure the electric current. The smaller unit of electric current, smaller units of electric current. First one is 1 milliampere. 1 milliampere is equal to 10 raised to minus 3 ampere. When we will say the current is 1 milliampere, means when the current is 10 raised to minus 3 ampere. Similarly, 1 microampere. 1 microampere is equal to 10 raised to minus 6 ampere. When the current will be 1 microampere, that is the in ampere 10 raised to minus 6 ampere. So these are the two important smaller units of electric current. This much you have to be remember this one also. Okay. So this is the thing that regarding the electric current and the unit and the smaller unit of the electric current and the thing that the electric circuit. So these things you need to be remember that a very simple thing. What do you mean by current? Means current, it is nothing but the flow of electric charges in a conductor, and the formula for the electric current is I is equal to Q divided by T. The unit for the electric current, you must be remember that it is ampere, and when we will say the electric current is 1 ampere, that much definition also we need to be remember. So in the next class we will solve this some numerical problem related to the electric current. Okay, thank you.